Okay, so I guess I can go ahead and get started with this already. I'd like to introduce myself first. So my name is Jessie. I am a freshman from Texas, and today I will be talking about MOEMs, the competition for elementary and middle schools. So this is a topic on MOEMs. This is a math competition that is for elementary and middle schools. This presentation is geared more towards the elementary side of it. And this is what it stands for. It stands for Math Olympiads for elementary and middle schools. So that's what MOEM stands for. Okay, so a little bit about MOEMs. It is mainly an elementary and middle school Olympiad, although this presentation is geared more towards the elementary side of it. The contest format is 5 times 5 problems. So there is a total of 25 problems, but it is split between 5 different months. So the season starts in November, and each month you take a test, and March is the last month that you'll take the test. And so your total score is just the sum of your score from every 5 of the contests. And so some prizes, individual prizes, if you are in the top 50%, you get a patch and a certificate. If you are in the top 10%, you get a blue pin. If you're in the top 2%, you get a gold pin. And finally, if you get a perfect score, you get the Dr. George Lenchner Award. And it is it's like a bronze medallion. Yeah, and it has the MOEM symbol on it. So these are the main individual awards that you can get just from this competition. And so moving on to team awards. So team awards are based on the registered school and organization. So for instance, if this is based on one school, you can't have students from multiple schools forming a team. Otherwise, they're not eligible for team awards. But a silver trophy is given to individuals selected as the honorable mention. Again, this is up to your coach to decide who to award this to. Usually this is done by scores. It should be done by scores, but this is for the coach to order. And so this just recognizes outstanding team members and also high scores. So you can get an honorable mention, which is a silver trophy through the team. And then finally, the gold trophy is given to the highest score individually. So between your registered team, school, or organization, the highest score is going to get a gold trophy. And it's the same size as the silver, but it's gold, and it says highest individual score or something on the top. And then finally, you can get a plaque. This is more for the school, organization, or coach, but this is awarded to the top 10% of teams. They're eligible to get this award. Do note that if your MOEM's team is like a district and it has students from multiple different schools, then your team is not eligible for this award. This is just for individual schools and organizations that register. And then, of course, every participant is going to get a certificate with their name on it for the successful participation of the MOEM season. So that's mainly it about awards. Does anybody have any questions on awards or format or structure? Okay, well, since I don't see any questions, I'm going to move on. So now I'm going to move on to some of the problems. Again, these are more problems that have already happened in elementary contests. So these problems are going to be a little bit more on the elementary side, but I'm still going to give you enough time to solve the problem and attempt it yourself. So the first problem we're going to have says, if 20 is added to 1/3 of a number, the result is double of the number. So what is the number? So if you have an answer or an idea, feel free to drop it in the chat, private message it to me. So, and I'll probably message you back if it's correct, or if you're on the right track, or I might ask for your ideas as well. Some of you are actually pretty close with your answer. Some of you are 1 digit off, so I would just recommend rechecking your work and testing to see if the number fits the equation. I'm going to wait about 1 or 2 more minutes just to give other people a chance to try and solve the problem, and then I'll start explaining it. Okay, so I guess I can start going over this problem. All right. Okay, so our problem says if 20 is added to 1/3 of a number, the result is equal to double of the number. And so we want to find what this number is. And so we can first start by calling this mystery number x. I think that's a variable that most people are pretty familiar with. So we will call x the number. All right, and so we can set up an equation given the information. So we find if 20 is added to 1/3 of the number, the result is double of the number. And so since we want to find x, we want to isolate x, so move it all to one side. So it would be easier if we moved the x over 3 to one side. So by doing this, we can subtract x over 3 from both sides. And this will cancel out. So this will leave us with 20 equals 6x over 3 minus x over 3. I know you can't see this, so let me move the screen. Great, so we have this at the end. And so we can see that this is equal to 5x over 3. And then finally, our last step is just to multiply both sides by 3/5 because this will isolate x by itself. So 20 times 3/5 is going to give us x. Therefore, 12 is equal to x. So we can plug this back in and try it. Is that can help us clarify our answer? So if we plug this back in, 20 is added to 1/3 of x, so that is 12 over 3. We want to see if that is equal to 2 times 12. So this is going to be 4. So let me move that more. Since that's going to be 4, we can plug this in and get 24 equals 2 times 12, which is 24. And we see that this works. So our final answer is going to be x equals 12. Right? Are there any questions regarding that specific problem, or can we move on? Okay, well, since I don't see any problems, I'm just going to move on now. And so we can move on to our next question, which reads, in the magic square to the right, 5 more numbers can be placed in the boxes so that the sum of the 3 numbers in each row, in each column, and in each diagonal is always the same. So we want to find what value should x have. I'm going to give you guys a few minutes to try and solve this problem, and then I'll go over it and explain it. I know this is a generally longer problem to solve, but if you get an answer or even an idea, just feel free to type it in the chat. Even if you have an idea and you privately message me with that, I can still give you hints to help guide you solve the problem. Just make sure that you're privately messaging me so that you don't spoil the fun for other people. Okay, I'll give you guys a few more minutes to try and solve this problem, and then I'll go over it. Okay, well, I guess I have enough responses in the chat, so I can go ahead and go over this question. All right, so I think you guys have already seen the question. It's just saying that the sum of the diagonals and rows and columns are all going to be the same. So first we want to find what this magic sum is, right? We want to find what the sum of every row, column, and diagonal is going to equal. So if we look at this column specifically, we can find that these add up to a certain number, and this is actually going to equal our magic sum. So we want to try to find the sum of 15, 50, and 25. So we have 15 plus 50 plus 25, and this is equal to 90. So we know our magic sum is going to be equal to 90. And so now we can look at this diagonal right here. We have a 25 and we have a 35. And so we want to find the number in the very middle square. So we can just subtract 25 and 35 from the magic sum, which is 90. This gives us 90 minus 25 minus 35 equals 30. Therefore, this middle number is going to be 30. And then finally, we can look at this very top row. And we can, here we go. We can look at the very top row, and we can try to find what number goes in the middle of that row. And so our magic sum is 90. We're going to subtract a 15, and we're going to subtract a 35, which is going to give us 40. Okay, so we finally know this number in the very top is 40. And so now we can just find x just by using this column right here. So by using this column, we know that the magic sum is 90. We're going to subtract 40, and we're going to subtract 30. And this is going to give us 20. I know this is kind of hard to see. There we go. So this is going to give us 20, which is our final answer. So right here, x is equal to 20. All right. So if anybody has any questions with that, please put it in the chat. I'll see your messages and I'll respond and try to help you and give you some hints. But as for right now, I'm going to move on. So the next question that we have says, an acute angle is an angle whose measure is between 0 degrees and 90 degrees. So using the rays in the diagram, how many different acute angles can be formed? The measure of angle ABC is less than 90 degrees. Okay, so I see enough responses in the chat that I'm going to start going over this. Okay, so I think we all know the problem already. So I'm just going to pull up the diagram. And it looks like that. All right. And so, okay, so this is what we have with our diagram. And so this is just 5 rays. All right. And so an acute angle, to form an acute angle in this diagram, we just have to choose 2 of the rays because they're going to intersect at point B, and that's going to give us an acute angle. And we know that choosing even the largest angle, which is angle ABC, is valid because the question tells us angle ABC is less than 90 degrees. So it's also an acute angle. And so the really fast way to solve this is just to do 5 choose 2, which is going to give us 10, because this is equal to 5 times 4 over 2 times 1, which is 10. But if someone isn't familiar with combinatorics yet, I can just go ahead and show you the counting way. So the first way we can do this is by counting the number of angles we have of different sizes. So case 1, angles next to each other. So I'm going to call them 1 angle, because it's just a combination of 1 angle in this diagram. So we have 4 different ways to do this. We have this angle, this angle, this angle, and that angle. So this is going to be equal to 4. Then we have case 2, 2 angles. And the way I describe this is that we're going to have 2 of these small angles connected together. So like this, for instance, would be a valid, case. In order to make this easier to see, I'm going to switch to purple so we can count how many we have. This is number 1, where we're squishing 2 of the smaller angles together. Number 2 and number 3. This is going to equal 3. So we have 3 different ways to choose 2 angles that are next to each other and combine them. So then our next case is 3 angles. And so this is similar to the last case. It's just where we combine 3 of them together. So for instance, this would be 1, and this would also be 1. So we only have 2 cases for this one. And then finally, our very last case is just the big angle itself. And that's just going to be 1 because we only have 1 gigantic angle, which is angle ABC. And so finally, we can just total this sum. 4 plus 3 plus 2 plus 1 is going to equal 10. And that's our answer. So there are multiple different ways to do this problem. You can count the number of angles there are because it's a relatively small number to count, or you can just go ahead and do 5 choose 2. So either way is going to land you the right answer. And if anybody has any questions, please put them in the chat. But I'm going to move on to the next question, which reads, 5 days before the day after tomorrow was Wednesday. What day of the week was yesterday? Okay, so I think I got a lot of quick responses on this question, which is amazing. I think a lot of people were able to solve this problem relatively easily. But if not, then that's okay. I'm still going to go over the problem. So this problem reads, 5 days before the day after tomorrow was Wednesday. So what day of the week was yesterday? Okay, so I think the easiest thing first is to draw a calendar. You have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, and so it tells us 5 days before the day after tomorrow was Wednesday. So 5 days after Wednesday, we can count 5 days. One day is Thursday, Friday, Saturday, Sunday, and Monday. So counting 5, the day after tomorrow is Monday. Day after tomorrow. Oh, I know that's a weird abbreviation, DAT. Day after tomorrow. Okay, so the day after tomorrow means tomorrow is going to be Sunday. So that's what tomorrow is. Tomorrow is Sunday. So since tomorrow is Sunday, that means today is going to be Saturday. And if today is Saturday, then yesterday was Wednesday. Not Wednesday, sorry, Friday. So our answer is indeed Friday. Yesterday is a Friday. And this really doesn't have a trick for this problem. The fastest way really is just to count the days. And these types of calendar questions come up on the MOEMS competition a lot, especially for elementary students. So yeah, they usually try to put some tedious problems that are still doable. So just be on the lookout for those. But assuming there's no more questions, I'm going to display the next problem, which says a number has a remainder of 1 when divided by 4, a remainder of 2 when divided by 5, and a remainder of 3 when divided by 6. So what is the smallest number that has the above properties? All right, so I'll just get on with the explanation. So this is a pretty tricky problem. This is actually number 5 on the list. Oh, yeah, do you have a question? You can ask it right now.
No, but I just sent the answer because.
Oh, okay. All right, so all right, here's the problem. Let me see if I can make this bigger. There we go. That's better to see. Okay. So this looks like a pretty tricky problem at first because you don't want to try every single number because that's going to take a lot of time, and you don't want to spend a whole lot of time on this contest because you only have 25 to 30 minutes. And so let's first write it out. Let's see if we can notice a pattern. So divided by 4, this number, let's call this number n, okay? I don't know if anyone is familiar with modular notation yet, but this line just means remainder. So when I write 1 mod 4, this means that when n is divided by 4, it has a remainder of 1. That's just what this notation means. And we also know when it's divided by 5, it has a remainder of 3. Oh, a remainder of 2, sorry. And then finally, when we divide it by 6, we get a remainder of 3. Okay, so this looks pretty interesting. We can see that 1, 4, 2, 5, and 3, 6. We can see that there's definitely an arithmetic correlation between these numbers. And it's not because 1, 2, 3, and 4, 5, 6 are consecutive numbers, but it's because we can notice that 1 plus 3 equals 4, 2 plus 3 equals 5, and 3 plus 3 equals 6. So it's always going to be 3 less. And so what this type of problem is saying is that if we find a number that's divisible by 4, 5, and 6, and we subtract 3, that's going to give us the smallest number of n. So let's find the LCM of 4, 5, and 6, right? So LCM 4, 5, and 6. Well, we know the LCM between 5 and 6 is 30, but 30 isn't divisible by 4 yet. So if we double this, we're going to get 60. And we find that this is the LCM. This works for all the numbers. So now we know the LCM of 4, 5, and 6 is 60. By the way, LCM is just least common multiple. So that's the smallest number that can be divided by 4, 5, and 6. So we have 60 now as our LCM. Since n plus 3 should equal 60, we find that 60 minus 3 is going to equal n. And this is 57. So 57 is equal to n. So that should be our final answer. And yeah, I can see this would be pretty hard if we listed every single number. But the trick for these types of problems is just to notice a correlation between the numbers, usually an arithmetic correlation, and then find the LCM and subtract. Okay, well, I hope there's no more questions. In that case, I'm going to move on to the next problem. And this tells us 3 water pipes are used to fill a swimming pool. The first pipe alone takes 8 hours to fill the pool, the second pipe takes 12 hours, and the third pipe alone takes 24 hours. If all 3 pipes are opened at the same time, how long will it take to fill the pool? Okay, I think for the purpose of time, I'm just going to go ahead and go over this question. All right, so I have the problem up here. So there are two ways to do this problem. I think the easiest way, at least for elementary, is just to set a number of gallons for the pool. So let's find the LCM of 8, 12, and 24. The LCM of 8, 12, and 24 is 24. Let's just say there's 24 gallons. So for the first one, since it takes 8 hours to fill the pool, this one can fill 3 gallons an hour. The second one can fill 24 over 12, which is 2 gallons an hour. And the third one can only fill 1 gallon an hour. So that's why it takes the longest. So if they're open at the same time, you have 3 plus 2 plus 1 equals 6 gallons. So altogether, they can fill 6 gallons an hour if we open them together. And so finally, since we pretended that we had 24 gallons, 24 over 6 is equal to 4. Personally, I believe this is probably the easiest method of solving this. But I mean, a similar way we can use harmonic mean for these. This is generally a more advanced concept that I really don't expect anyone to use on this competition. But harmonic mean is really just 1 over 1/8 plus 1/12 plus 1/24. So we want to simplify this. And this just uses pretty much the same ideology as we did with pretending that there were 24 gallons in the pool. We can simplify this all to a common denominator. 3 plus 2 plus 1 over 24. 1 over that. That's what it simplifies to. This simplifies to 1 over 1/4, which is equal to 4. So this is the same method using harmonic mean. It's just it saves you a step by setting the pool to a certain number of gallons. But I think this is also the more confusing way. So if just setting the pool to a certain number of gallons helps you, I would just stick with that way, because that's the way I used to solve most of these problems in elementary school when I was doing these contests. But yeah, so I hope everyone understood that problem. I'm going to go ahead and move on to the next problem, which says the complete outside including the bottom of a wooden 4-inch cube is painted red. The painted cube is then cut into 1-inch cubes. So how many of the 1-inch cubes do not have red paint on any face? Okay, so I know this is probably a harder problem to tackle, but I can go over it right now. Just for the sake of time, I guess. Okay, so for this one, we actually don't need to draw a cube. So, but just for visualization purposes, I will. Oh, that's a bad cube. It's okay, I'll just draw a 4x4 square. I think that represents each side. Okay, so it looks like this. And so if we paint this entire face with paint, we have 4 layers of this. So all the outer cubes are going to have paint on them. So instead of trying to subtract how many outer cubes there are with paint on them, we can just try to directly find how many don't have any paint on them. So if we consider this cube to have depth, it's going to look somewhat like that. I know the lines aren't very straight, but it's going to somewhat be like this. Like this, okay. So, okay. So we're going to see all of the outside cubes are going to have paint on them. So if we visualize it just like a cube like this, the only cubes that don't have paint on them are going to form a little cube of their own on the inside of the cube. So all of these cubes, I should change colors just to demonstrate this. All of these cubes on this first row, they're all going to have paint on them. All of these cubes as well, they're all going to have paint on them. These as well, these edge cubes, and then this bottom cube. And of course, like these cubes in the middle, the ones that I haven't crossed out yet, they're going to have paint on them. But if we think of a layer under them, they're not going to have paint on them, right? Because they've been on the inside of the cube. And so an important thing to understand with solving this problem is to be able to visualize a small 2 times 2 times 2 cube on the inside that isn't affected by paint, because we subtract one side here and one side here because they both have paint on them. So 4 minus 2 is going to equal 2. And so on the inside, there's going to be a 2 times 2 times 2 cube. The volume of this is 8. And so our answer is going to be 8 cubes. All right. Alternatively, we could just subtract the ones that do have paint on them. I think it works better with smaller numbers if we try to do this, if we try that approach. But I generally just stick to the 2 times 2 times 2 approach, where we subtract 2 off each side and then cube that. Okay, so that is my approach. We're down to 3 more questions. We can try to get them solved pretty quickly. Okay, so I think I can just go ahead and go over this one. So moving on to this problem, it says the age of a man is the same as his wife's age with the digits reversed. So the sum of their ages is 99 and the man is 9 years older than his wife. So how old is the man? So let's call the wife's age X because we know the wife is the younger one. So the wife's age plus the man's age, which is X plus 9, is going to equal 99. And because it's given that the man is 9 years older than his wife. So combining this, we get 2x plus 9 equals 99. 2x equals 90. X is equal to 45. So this is the wife's age. Now we can just find the man's age by adding 9 to that. So x plus 9 is equal to 54. And we can indeed see that 54 is 45 reversed. So the man is 54 years old. And that's the method for solving this question. Please let me know if you have any questions. I know I'm going fast on these last few. Okay, so this is actually a pretty interesting problem. If the digits A, B, and C are, oh, I need to make myself smaller. There we go. If the digits A, B, and C are added, the sum is a 2-digit number shown on the, is a 2-digit number AB shown on the right. So what is the value of C? Okay, so I can go over this problem now. Okay, so we are given this. A plus B plus C equals AB. So in order to solve this problem at first, it's easier if we subtract B from both sides. This is going to give us 0. So A plus C is equal to 10 times A. And so we know 2-digit numbers, if we have 2 single-digit numbers adding up, the maximum the sum can be is 18, which means if we have a 2-digit number, A has to equal 1. And so when A is equal to 1, you can change this. This is just equal to 10. 1 plus C is equal to 10. C is equal to 9. And that's just the fast way to solve this problem. All right, I think I have 1 or 2 more problems. But yeah, let me see if we can get through all of them today. Okay, I have a few more. Let's do one final problem. Oh, this one's pretty interesting. Let's do this one. Oops. Here we go. Okay, so it's almost 5, so I'll just go over this problem really quickly. But yeah, this one is actually quite misleading because you don't need to know a lot of the information that's given to solve this problem. So this problem reads, I have a drawer which contains 40 socks. We really don't need to know. We just need to know how many different types of socks there are. So we have tan socks, brown socks, gray socks, and blue socks. So we want to see the least number that you have to draw to be absolutely certain that you have 2 socks of the same color. So in this case, we just have to pretend that we're super unlucky when we're drawing. So let's say first I choose a tan sock. Next I choose a brown sock. Next I choose a gray sock, and finally a blue sock. This is going to equal 4. So the unluckiest method is if we have 1 of each color once we draw 4. So now that we have 1 of each color, if we draw 1 more, that means we draw 5 socks. That guarantees that we have at least 2 socks of the same color. Yeah, that's also correct. Your answer is correct. And so we don't need to know, there's 40 socks. We don't need to know how many there are of each one. We just need to know how many different colors we have. And so our answer for this one would just be 5, right? Okay, so that pretty much concludes this presentation on molems. I want to thank everyone for joining, and thank you for everyone for participating actively. And so for more workshops, you can visit the URL below. And yeah, that's it. The workshop has concluded. So thank you everyone for coming.
Bye, thank you.
Thank you, bye.
Thank you, bye.
Thank you. Maxie, Eddie, and Lilac, do you guys have any questions? I can stay behind if you want us to answer questions if you have any. But if not, then this workshop is concluded. So thank you for being here. Lilac, do you have any questions? If you have any questions, just feel free to unmute or put them in the chat. But otherwise, the workshop has concluded. So thank you for joining.